All right, we're going to look at the natural logarithmic function. Okay, and this is used kind of in conjunction when you see e. So when e is used as the base for your exponential function, like we looked at in section 4.5, computations are easier with the use of a different log function. So this is called log base e, or the natural log of x. Okay, and the way that we write that is that y is equal to ln of x. So previously we had y as log of x, the common log, which is paired with that 10 to the y. So 10 and common log go together. E and natural log, or e and ln, are the two that go together here. Okay, so y is equal to ln of x is the same as e to the y is equal to x. So we're going to rewrite these statements using exponents instead of logs. So ln of 20.0855 is equal to 3. I can rewrite that as e to the third is equal to 20.0855. And then ln of 0.36787 is equal to -1. It's the same as saying e to the -1 is equal to 0.36787. We're going to fill out these natural log properties. These are going to look really similar to the ones we had for common log. So ln of 1 is 0. Okay, and the way that I remember that is I know that e to the 0 is equal to 1, because anything to the 0 is 1. And so if I reverse that, then ln of 1 is 0. Let's see, this should say ln of e. So ln of e is equal to 1. And ln of e to the x, so ln and e are best friends, they're inverses. So that just gives us the x back out. And then similarly, e raised to the ln of x gives us just this x back out, or whatever happens to be there as that input. And the law of logs remains the same. So ln of AB is ln of A plus ln of B. Ln of A divided by B is ln of A minus ln of B. And then ln of b to the t, same deal as before. We bring that t down in front, so we get t ln of b. All right, and then one last thing before we move into more solving. We're going to solve for x here, but these ones are special. So what you see here is these have the same base. It's 2 raised to 2x plus 2 is equal to 2 to the 3x. So since they have the same base, this simplifies to 2x plus 2 is equal to 3x. And if I subtract 2x from both sides, I get x is equal to 2. Okay, so this trick does not work if you had something like 2 to the 3x is equal to 5 to the negative x, because they're different bases here. So this trick doesn't work for that. It only works if you have the same base. Okay, and similarly, if I have the same log, so this happens to be that I have the natural log for both of these, then this simplifies to 5x is equal to 2x plus 9. Right? Because the only way that ln of 5x would be equal to ln of 2x plus 9 is if 5x equals 2x plus 9. So we would get that same thing inside. And I can subtract 2x from both sides. So I get 3x is equal to 9, which tells me x is equal to 3.